Hello, class. Well, you survived the first week. We're on our second week now, and gonna go on. And here is this week's article, a new topic, and it's about using copper Godzilla spikes to lower the energy needs of for data processing centers. So AI is becoming more and more prevalent, and we use it. I've started using it myself, even, and uh, one of the things that AI requires is just a huge amount of computation and data storage, and so well, and we have these huge data centers, and among other things, they draw a huge amount of electricity from our grid, and this is increasingly, it's going to become more and more what we use our energy for. So what we use electricity in general, we use quite a bit of it for climate control, quite a bit of it for cooking, lighting, and increasingly more and more computers. And it's going to become more. I mean, of course, we use electricity other ways too, but things like industrial processes. I mean, like moving robots to make stuff in factories, that kind of thing. But I believe that the most we use electricity for is climate control. But as I mentioned before, AI is becoming more and more prevalent. So more and more of our grid's demand is going towards these data centers. And of that, 40% of the energy goes by data center goes to cooling the chips. So, what our computer technology is based on right now basically is transistor logic that comes from the band gap of silicon, meaning that if something conducts, it has it's a one in logic. If it doesn't conduct, it's a zero. So, and based on the 5 volt transistor logic function, and also because we put electricity into it, and there's a little bit of resistance, computer chips get hot, and we have to cool them down. And right now, I think it's a quad. My laptop's a quad core. Maybe it's an 8 core. I'm not entirely sure. But we've gotten to the point now where we're piling more and more processors are on top of each other. So lots of heat there, lots of heat being generated by electricity, and now we're using electricity to cool it down. And just by using air circulation, these data centers, the electricity draw they have, 40% of the energy draw is to cool down these chips. But so copper conducts heat very well. So actually we haven't talked about periodic trends yet, but everyone in the copper family, copper, silver, gold, they conduct electricity and heat very well. They're great thermal and electrical conductors. In fact, silver is the most electrically conductive element. Of course, silver is a bit more expensive than copper. Copper is cheaper. But they've used various techniques to make these fins. And they say these look like Godzilla fins. So, and then not only that, they run liquid through them. So this is polypropylene glycol and water. So this is a very common heat transfer. In our cars, we use ethylene glycol. Propylene glycol is 3 carbons. Ethyl is 2, propyl is 3. So 3 carbons, 2 OHs. So 3 carbon chain, 2 OHs. That's a propylene glycol, and it has a very high heat capacity, and it's also safer. Propylene glycol is safer than ethylene glycol. You can drink a little bit of it. So if you ever, those of you that are over 21, if you ever drink Fireball whiskey, it has propylene glycol in it. So. But that's not so controversial in the United States. Europe, it's a little more controversial. I always kind of found it amusing because the cure for propylene glycol poisoning is actually ethanol. So you have the toxin and the cure all in the same one. But okay. So this is a very common heat transfer medium, water propylene glycol mixture, and it's a very safe one. and it cools. This liquid cools much more quickly than air. I remember. So changing topics, when I was looking at the meet and greet forum, I started off. I looked at there's a lot of engineers here. It turned out all the engineers answered first, so I thought we're gonna have a lot of engineers in this class. But we still do have quite a few engineers. But you are now. I thought it was gonna be overrepresented. Now we're underrepresented. There's a lot. I see a lot more scientists coming in. But this, I thought about I have a degree in engineering, chemical engineering. I thought about this as a heat transfer problem. This is kind of interesting. So for you engineer folks, you have the heat source as the computer chip, and then you're going to have, so you have the computer chip under this, and then you're going to have conduction heat transfer out to the fin, and you're going to have the high to low, and you're going to have it's a linear. When you study heat transfer, it'll be a linear process there. And then when you get to this, you're going to have Newton's law of cooling, where you then have it follows the exponential decay. So you have the high temperature, then you're going to have the linear heat transfer, then you're going to have the Newton's law of cooling across that. So I don't know if I guess I went out of the screen. So you have the high temperature source, then along the copper, then you have the Newton law of cooling. So I was running that in my mind. You can learn about that later if you study heat transfer. That heat transfer is not in this class at all, so don't worry about that. But one of the reasons why liquid is much more efficient than air is, generally speaking, there's about 1,000 times as much matter in liquid as there is in air, right? You can flap your arms here in air. I can feel the wind on my fingers. But if you go into water, you go like, you have to push all that water out of the way because there's just a lot more matter to push out of the way. If there's more matter, that means there's more collisions, there's more opportunities for the heat to flow from hot to cold. So this is not magic. This is just good old-fashioned. More matter means more things cooling. Also, you can cool the ethylene glycol. I'm sorry, it's propylene. You can cool the propylene glycol water mixture. You can bring that below freezing water temperature. So didn't mention what temperature you have on this, but then this brings the amount of energy used down to about 1%. So, and that's a big drop from 40% down to 1%. That's a big drop down. And like if you look at this, I mean, copper is not the cheapest material. It's not the most expensive, but it's not the cheapest material. And it's in pretty high demand. But of course, computer chips are small. So I mean, that's the nice thing about this. That we're not I mean, it's not like look at steel. We make a lot of things out of steel. You make buildings, you make cars out of steel. Computer chips they're pretty tiny. So and these layers are on the order of millimeter, and it's not even a square millimeter, right? So it's making making the grooves here. So the point of this, though, why am I talking about this? The point of this is that we're using chemistry and techniques and combined with engineering. So chemistry is sometimes referred to as the central science. So a lot of things radiate out from chemistry, and we're doing it to solve a problem. In this case, the problem, well, we're getting more and more data centers. Artificial intelligence is becoming more prevalent. We need more data centers. That's putting a huge drain on our electrical grid. So what do? The easiest answer, we need to build more power plants, right? So that's one of the things we can do, and we are going to do that. The other thing is, well, what can we do to make things more efficient? And this is one of the things that we can do to make things more efficient. So it's a combination. This is also green chemistry. So looking at, and you look at environmental things as many faceted. This is one of them is efficiency, and this is a great way to increase efficiency. And although I don't want a liquid cooled laptop, I also, my laptop is not running strongly all the time. But for a data center that is running at very high capacity and then the processors are going, generates lots of heats. This is a good idea. And although it requires capital up front, but the efficiency savings are great. This is one of those chemistry is useful. It's like, why am I taking this class? Like, unfortunately, you're taking this class because chemistry is useful. And here's an example of how chemistry is useful. And this is an example of how we're using chemistry to improve our lives and solve a problem. And if you look at this, so I know this is multidisciplinary. I mentioned the heat transfer with the engineering, but I mean, this is the rest of it's mostly just simple chemistry, right? Copper's an element. It has certain physical properties, specifically thermal conductivity, and then you have another medium, in this case, a solution of water and propylene glycol, which is a liquid, which is a different state than air, so states of matter, that kind of thing. And then the idea of atoms and molecules, well, there's just more concentration of matter in the liquid than there is in air, and because of that, you get more rapid heat transfer, which was the problem. The initial thing is to get more efficient heat transfer to lower the electrical load. So I hope you enjoy the article, and when I see stuff like this, it makes me hopeful. So I do daydream about the future, where things are. I'm looking forward to my robot that's going to come in and cook me dinner, do my dishes, and fold my laundry. You know, that I can't wait for that to happen. And I know, but right now we're on, we're at data centers, and of course I like to do stupid stuff with AI. Like take pictures of my friends and say, make my friend look like Cleopatra, kind of thing. I think I'm not the only one that does that, and that's all AI, is doing that. So, and this is how we can continue to take pictures of our friends and make them look like He-Man, or like I said, I've done Cleopatra. I haven't done He-Man yet, so maybe I'll do that soon. So, okay, well, I hope you enjoy the article, and hope you're enjoying the class so far. And I saw last time I checked, there were 30 people signed up for mastering, and we need about another 10 people to sign up. I haven't started to bug those students yet, because you still have some time. I know some people have some financial obligations for that. I'll start bugging people more after the first due date. I mean, one of the things is summer class, we don't have as much time, so things have to come quickly, so. But if you ever need anything in general, if you're feeling overly anxious or you're dealing with other mental health crises, if you're having a hard time with your basic needs, you don't have a place to live, you're not getting enough food, or if there's something else that's happening, feel free to reach out to me. One thing that's nice about being a professor is I'm very well connected in the community, and whenever I ask for help, it's very rare that people tell me no, or they don't point me in the right direction. So if you do feel some challenges outside of chemistry in the terms of the I'm a human and I have a problem issue, feel free to reach out to me, and I'll do what I can to help you. Okay, and that's good for everyone too, because I want you to succeed. You want to succeed. I want you to do well in the course, and you can't do well in the course if you are struggling with these issues. So, but take care for now, and I will see you next week. Goodbye.